So to start out the urinary system, we're going to look at an overview of the anatomy and physiology of the kidney. So the urinary system consists of the kidneys, which filter the blood and therefore control, or not control, but influence many other body systems. The ureters that take urine made from the kidney down to the urinary bladder, and the urethra, which voids it from the body, as you can see these labeled in the figure on the right. So the urinary system maintains homeostasis because as they filter the blood, they manage blood volume and fluid in the blood. And they also maintain things like pH and ionic concentration and osmolarity. So as it maintains blood ionic composition, pH, osmolarity, also glucose, blood volume will also contribute to blood pressure. The kidney releases its own hormones like erythropoietin, which stimulates your red bone marrow to make blood cells, and calcitriol, which allows you to absorb more calcium from your intestine. And it also excretes waste and toxins, so the buildup in your body of that, if your kidneys weren't working properly, will affect all other body systems. So kidneys are located there against the back body wall. So you can see in this image, this is a transverse section toward the bottom of the screen, or the vertebrae and musculature of the back. That's around the second lumbar vertebrae. Notice that these kidneys have several layers as they are retroperitoneal, so they are not housed within the peritoneum, the largest serous membrane of the body. They have this clear renal capsule giving it its shape, but they're also packed with lots of adipose tissue, so fat tissue around the kidneys for protection. Then they're held in place by dense connective tissue called renal fascia. They're protected by the lower two ribs. You can see here in a sagittal section through the kidney a little bit better how that renal fascia holds it there in place, and it has all of that adipose tissue around it. The renal capsule that is clear and gives the kidney its shape is continuous with the ureters, which are about 1 foot long and leads down to the posterior area of the urinary bladder. So those ureters are also retroperitoneal. As we see a cadaver in a drawn figure of the kidney, we see the renal hilum or hilus is an indentation on the medial side of the kidney, and the ureter leaves from that, but we also have innervation in there, and we have the renal artery and the renal vein. The renal artery brings blood to the kidney, and the renal vein takes blood away from the kidney. And at rest, the kidney receives something around 20% of your resting cardiac output, so pretty significant about the amount of blood that goes into the kidneys. There are also lymphatics coming in and out of that renal hilum. So we could divide the kidney cells or the tissue into several regions. The cortex is the outer layer, whereas the medulla has inner sections of cells. When we look inside the medulla, we're going to see two structures we can divide it into. That's pyramids and columns, so just showing you in this figure. This lie area that the mouse is running around is the renal cortex, and then this area that has these triangular structures, these are known as renal pyramids. The light tissue going in between the pyramids are known as renal columns. And then within these renal pyramids, there will actually be many structures known as nephrons, as you see just one here, or really two nephrons and a collecting duct outlined in yellow. And those nephrons are set at the time of birth. Unfortunately, there is not repair of nephrons if they are damaged, and nephrons are the functional units of the kidney. So as they are damaged, you decline in kidney function, and they are not replaceable. But any growth in the size of kidney is not adding new nephrons, but growth in the nephrons that we have. So we'll spend a lot of time on the nephron as it is the functional unit of the kidney. The blood supply, we said, receives about 20 to 25% of resting cardiac output, and there is sympathetic outflow from the kidney. So we'll see later that the sympathetic outflow can largely affect blood vessels going in and filtration of the kidney. So when we look at the structure of a nephron, we're going to identify several regions. As we said, this is the functional unit of the kidney. It's got this round region up in the cortex. So if we look at where this figure is from, this light tissue is at the top in what we call the renal cortex. And this darker area at the bottom is denoting a renal pyramid in the medulla. But this is known as the renal corpuscle. And then coming away from the renal corpuscle is something known as the proximal tubule. The proximal tubule gives rise to this loop that dips down into the pyramid, into the medulla, known as the nephron loop. So you've got the descending limb of the nephron loop, and then the ascending limb of the nephron loop. Then the distal tubule. The distal tubule goes into a collecting duct, which is this long structure. And as we saw in this prior figure, more than one nephron may go to a collecting duct. So we can see another figure showing, as I run my mouse around it, the renal corpuscle, the proximal tubule, the descending limb of the nephron loop, the ascending limb of the nephron loop, the distal tubule, and the collecting duct. And this one is oriented a bit differently, as different drawings will have the nephrons stretched out and oriented a bit differently depending on where it's from. There are two capillary beds rising, really three capillary beds here. As the blood supply goes into the kidney, the afferent arteriole will give rise to a very important capillary bed known as the glomerulus or glomerular capillaries. And this is where we filter constituents of blood into the nephron for functionality. The efferent arteriole leaves the renal corpuscle area from the glomerulus, but it gives rise to two other capillary beds. The vasa recta, which supplies blood to the nephron loop in the medulla, and the peritubular capillaries, which head on out and eventually become the renal vein leaving the kidney. There are two types of nephrons, and we'll see how later on they both function different in the kidney, but 80 to 85% are cortical nephrons. And then the other 20 to 25, or other 20%, 15% are juxtamedullary nephrons. And if we can see the difference, the one over to the left side is the cortical nephron. Notice it sits higher up in the cortex and its nephron loop dips barely into the medulla, whereas the juxtamedullary nephron, which we have in much less percentage, dip further down into the medulla. They have long nephron loops and long vasorecta capillaries supplying blood to them. And we'll see one of the functions of those fewer juxtamedullary nephrons is that they help maintain an osmotic gradient in the medulla that allows us to make correct and concentrated urine. And we will see that in a deeper physiological process. So juxtamedullary, juxta means next to, and medulla. So it just means that it's a nephron, that it goes deeper into it. It means next to the medulla.